This question involves energy transfers and work done. Therefore, we can use the work energy principle to solve it. As usual, at first, we have to visualize the situation. So read the question and draw a diagram. So let's consider the initial and final situations or energies of the bullet. Initially, the bullet has a speed of 50 meters per second and therefore has some kinetic energy. The final situation sees the bullet embedded in the target, or at least partially inside the target, but stopped and therefore has zero kinetic energy. In this case, there are no changes in potential energy because the bullet remains level. So considering the work energy principle, the total mechanical energy initially is simply the kinetic energy of the bullet, which is given by a half times the mass times the speed squared. And there is no gravitational potential or changes in it, and there's no elastic, of course, involved. So we have to add to that any work that was done on the bullet. But what work was done? Well, in this case, there was a force applied by the target in the opposite direction to the bullet, and let's call that force F, which we don't know. And that force acted through a distance d, which is the penetration distance of the bullet until it comes to a stop. So we write F times d. Of course, the force is in the opposite direction to the motion, and so the force has to be negative. And that is equal to the total mechanical energy at the end, which is the sum of the gravitational and kinetic energies. Since there is no kinetic energy, the bullet has come to a stop, and that's the final situation that we consider. There's no kinetic energy. We've considered zero gravitational potential energies, and so that becomes zero. So let's now substitute into the kinetic energy. That's 1/2 times the mass of the bullet, and of course it's 20 grams. So we have to write 20 divided by 1000 to convert to kilograms, times the speed of the bullet squared. So that's 50 meters per second, and that all is squared. Plus, of course, minus F, which is unknown, times the penetration distance, which is 1 centimeter, and of course 1 centimeter is written as 1 divided by 100 meters, and that equals to 0. Now I'm sure you can do the mathematics, and of course it gives you a force, which you will calculate, and it's measured in newtons. Enjoy your calculations.